There are some advantages to using carbon fiber over standard structural strengthening like rebar, wire mesh, and things like that. Number one, it's non-corrosive. If it goes into water full of salt water and acid, it won't hurt it a bit. Lightweight, it's high strength, and it's durable. It's as long as the substrate is still solid and ready to go, you're never going to lose the strength and tension for it. So it's awesome. Some of the structural strengthening examples that we do on a regular basis, this is actually a column confinement. What you can see here are these bridge columns, and over time, heavier and heavier loads come, and these columns tend to want to bulge. And so they require a thing called hoop reinforcement, which we do here, column confinement. And that's, if you can see it on the picture, this is CFRP banded horizontally. There's the seam right there, all the way up the top of the thing. And this one has a 6-inch overlap for bidirectional. Then it's coated with a special cementitious epoxy called an elastomeric stucco. I love this stuff, it's great. One of the problems, the largest problems that we're seeing right now is that some of our infrastructure is way past what its expected lifespan was. So again, these are column confinements. They wrap the column all the way down to the footer. In this case, they only needed to reinforce the very bottom of it. So you can see how they're all reinforced like that. This is a slightly different one. The slightly different one comes from a different style. This is actually got band strapping at the edges for buttered edge. I love this picture. One of the cool things about this is that it shows kind of the two different things we do with beams and slabs. This is shear reinforcement. When it goes up and over like this, it creates shear. And if you know about beams and how they work, shear only presents in the first third of the beam very prevalently, diminishing in the middle third, and then the second third, the third third on the other side where it comes up close to a contact point, there's more shear. So we do flexural and shear reinforcement on this beam. This is a shear reinforcement. They're usually called stirrups or horseshoes. This is a flexural reinforcement. It actually goes on the bottom of the slab. In this particular case, they had to take out some supports that were around here, and they needed to carry the load across those spans. So as they took these columns out to get more room for them to do whatever they were doing in this building, they needed a way to transfer that load. So they have carbon fiber in here all the way down as far as the eye can see to make sure that this room can then take the additional loads they're putting on top of it. Now, we talk about structural strengthening on the commercial side, but remember, some of those jobs in the commercial industry are a lot of work. I think I already showed you, but some of the things you got to remember on those for those big jobs: slower pay cycles, higher insurance rates, higher liability, some more OSHA concerns you may not be aware of, additional training for employees and supervisors, like the 30-hour, 10-hour construction one. If you're going into a mine site, it's MSHA. But here's the cake. Here's the real reason you want to go and look at that stuff. The commercial carbon fiber represents about $3 billion in annual sales. Actually, it's $3.2 billion this year. They're estimating it to go over $4 billion next year. And if you take the entire residential market and combine it, it's about 28 million. So it's much more. There's a lot more money in the commercial industry. So when people start looking at those heavy structurals and stuff like that, the reason they're oohing and awing so much is a small commercial job is $250,000 to $300,000. I have seen them as large as $3.2 million for the capital. There's no telling. There's a bunch of innovation things that are built into most recent congressional acts. 2018 had the Imagine Act, Innovative Materials for America's Growth and Infrastructure Newly Expanded, Imagine. And the cool thing about the Imagine Act is it encourages engineers, it encourages people to go forth and do a lot more with carbon fiber composites and fiberglass and things like that, because they get kicks from the Imagine Act to help fund their construction. The other problem we're having here is ASCE gives us a D- on all of our infrastructure across the country. That means that about 88 million trips are taken every single day against structurally deficient roadways and bridges. That is, those bridges should have been condemned But because we have to use them because we have no other choice, then it gets kind of hairy. So that's a little bit on that. So here's a tank for structural strengthening. Here's the tank on a water tank. This is a 3.2 million gallon tank in Las Vegas. They had a huge problem with us with the other way of working on it because they were so tight on water, which sounds funny that we were at a water treatment plant, wastewater treatment plant. But the reality is they were so tight on water that having the ability to say we didn't use water in our process was a huge benefit for us. What we ended up doing, the only water consumed on this site for the repair, other than these silly showers that we had to change out every day for 50 gallons, was the water that the employees drank. That was it. So this is column strengthening, very similar to what we showed before. It's a slightly different one. If you look at this, it will remind you very much of what our corner kit looks like. This is beam strengthening. This actually has flexural and shear replacement. So you can see there's a piece that goes straight down the middle. That would be the flexural reinforcement. That would be the shear reinforcement in these stirrups or horseshoes. Another type of slab strengthening is here, where you see 100% coverage. Spacing is all determined by our engineers. So don't worry that you have to do that. We have people who do it for you. One of the cool things about the carbon fiber that you're looking for that you can talk to people about is that it's sustainable and it's green. It really does mean add strength to the building where you need it, exactly where you need it, without having to tear the building down to do it. And for a lot of people, that means they don't have to tear a building down. They don't have to rebuild it. They don't have to do all the water for concrete, all of the materials being destroyed, all the materials have to be replaced, and so on and so forth. We literally put the structure and the strengthening exactly where we want it. So this is typical for crack repairs in a residential, but this is spalled and broken concrete on a poured foundation wall. Now in this case, I have one just like this in my house. I did the same exact thing they're going to do here. Strip out the crack, clean it all up, put an anti-corrosive on the bar to make sure that it's good. Then you reprofile it with an epoxy hydraulic cement or epoxy-based mortar. Use the Rhino epoxy here and put a piece of carbon fiber over it to reinforce the crack, to make sure that the crack isn't going to move again. Therefore, your crack installation is perfect. Actually, this is a blasting and fracking site. I love this picture because it shows like how big a crack can you fix? Well, you can see daylight through this one. Typically, we don't get a lot of these as the wall's typically falling down when that happens, but in this case, our engineers all work together with the people here to figure out a reinforcement pattern and make sure this building doesn't collapse. Unidirectional weave and carbon fiber weave, we talk about that a lot with you guys, and if some of you aren't 100% up to speed on it, let me tell you, unidirectional just means that all the carbon fiber goes in the same direction, one direction, like unidirectional. Generally, it's really good for beams, slabs, columns, piers, walls, all kinds of things you can do with it. But it allows you to focus the repair exactly where you need it. Bowing wall is sometimes done with that. Now, we have a really, really fantastic bi-directional we use in our bowing wall kits that I love. Here are the column wrapping pictures again. Typically, this is done with unidirectional. Sometimes it can be done with bi-directional. But bi-directional's great strength is that it gives you the carbon fiber weave in two different directions. It's commonly called a twill weave or a 2x2. It's depending upon who you talk to, but it's generally bi-directional. You get the force moving horizontally and vertically as it goes up and down the wall. But what people don't think about is that carbon fiber actually comes off from this point, going straight up and down. You give strength to the wall from 100% down to 50% at this lovely 45 degrees off. It's about 50% strength. But because you have it in this direction as well, coming back, you're always going to be at 100% between these 2 points. So it basically provides 360 degrees of rotational strength on the wall. It's one of the reasons our crack repairs are all done with the 12-inch carbon fiber that's bi-directional like this. I love this repair. It's actually one of those examples where we talk about multiple things going on, multiple things that have been done before. And we love the guys over at Sealed because They always walk through their entire thing. So what we showed them was, okay, so we have a leaking water repair. The water's coming in and it's actively coming in. So what they've done is they've stripped away all the old repairs. If you can see here, it's a big pile of caulking and all kinds of fun stuff that people do, and it doesn't make sense. Why are they keep doing it? And it keeps leaking. So he came in and stripped it all out, got bound into bare concrete, sealed it all off, put in a hydraulic cement in here, put his ports on the bottom, as you can see over here in the picture, the ports. When he goes to inject, what it'll do is it'll come up and it'll fill up all the cavities that are back here. But more importantly, it'll go in and find all those areas where there's water or water left, because we have a wonderful binary poly that will do that. As you can see, then what he did was he came back a little later after the injection was done, and they put on a carbon fiber crack repair fabric kit across there. And what it'll do, that crack repair will make it so that when the wall tries to move out of plane or does something weird, the wall will have structural integrity now across the crack, as well as an additional waterproofing membrane in the epoxy and carbon fiber. So it's a real win-win when you're talking about those kinds of things. Another way of dealing with crack repair that I really like is the concrete crack lock. And I talk about this one a lot. When we go to Vegas for the World of Concrete, we go through 200 of them that wander out of the booth because people can't understand how to leave them in the booth. Because once you touch one, you just want to use it. So you can stitch the cracks back together. It's minimally intrusive. It's non-corrosive. It's really blown up for us in the pool industry because every other repair method they have corrodes out. So if you look, this is actually a how-to. Give me 1 second for that to load up. So that's how the crack lock works. It takes all of 3 minutes to figure out how to teach you how to do it. So it's a pretty cool product. One of the things I like about it is it's not foolproof. Like, you can mess it up, but in reality, what we want you to get out of it is, whoops, sorry, that slide does not want to let go. what we want you to get out of it is it takes 2 minutes and 17 seconds to teach you how to put one in. It takes you about 6 minutes on average once you kind of get in the rhythm, put in the crack locks. It's pretty nice. We recommend using a 5/8 inch drill bit to do that, to go down 3/4 of an inch, primarily because it's a 1/2 inch ball and a 1/2 inch masonry bit, and your tolerances are so tight that it can sometimes get a little issue with you trying to do squeeze out with the epoxy. So this is one of our competitors in the market. They have a wonderful device called a torque lock. Its primary problem, for me anyway, is that you're putting more steel back into the pool, or in this case, yeah, the pool wall, and then you torque it and apply pressure to the concrete, and you can see when he torqued it, put it in, it cracked. He's actually putting excessive amounts of pressure on the pool side for that kind of a crack repair, and then they go and fill it up. But it's a lot of work. I've been told by someone who installs these that it takes on average about 45 minutes to an hour to install each one, whereas we're talking about 6 minutes. He's talking about an hour. In addition, the concrete crack locks are $130 for 20 of them, and that includes the epoxy to install them and all that fun stuff. And yet he does it; they're $440 for 10. So it's a very big difference in what you're getting out of it. So we're talking about making it $6 or $7 each, your cost plus labor, and they're talking about making them almost 50. So it makes a huge difference. These are steel staples, bent rebar. If anybody's used those before, just believe me, when I say you can. I've had people ask them. I've had people ask about them. I don't like them. Primarily, I don't like anything in a staple format because the wedge at the end of the staple is really where you put your force. So when you go to move this crack, you'll never realize the entire strength of this particular top piece, because each of these corners has a cutting wedge at the edge where it touches the concrete. When the concrete moves, it creates cutting shear, forces it into that corner, and it cuts off the bar way before it ever reaches tensile capacity. These are carbon fiber staples. Rhino uses carbon fiber staples. We have them in our repertoire. This is actually Luke Seacrest's garage at the shop. This is someone who lives with a footer. When they went to inspect the footer, they found that they had cracks. They called the engineer. The engineer gave them a layout for these crisscrosses on here, so they could lift from this spot they needed to put their pier, but everything else was fine. They put the crack locks in. It worked beautifully, in my opinion. I thought it was great. And then they now do it for all of their lifts. They don't even charge people for it. What they do is they say they went to go lift the house. They found the crack lock area where there was a crack, and they repaired it for free to set themselves apart from their competitors. We rate it right now 120,000 pounds per square inch. Much less concrete removed when you're then doing a staple or anything like that, because you don't have to create a channel. The width of the individual crack lock is less than the width of a cutting blade, a kerfing blade for concrete. So it's very fast, very easy, and the same kind of tools that you need. This is actually an installation. I can actually let you see. Wait, I took it out. Okay. So this is an installation that was done in Australia. As you can see, they're putting them up here. This was a balcony that had a rail on it. You can't see the rail over here because they took it off for the repair, but its anchor points are here and here. But it's this big wrought iron gate, or not gate, fence for the top of this balcony. And what ended up happening was, as the wind would blow, it would shake this thing and would create these stress fractures where from the support column over here, it would radiate out towards the edge. There's the edge, there's the edge. And we basically created a repair method that would work for them. And then they went and executed it. This is Ohio Department of Transportation. For those of you who think that you can use a crack lock to do just about anything, these guys were convinced they could. And so what you do is there are actually 4 of them deep. They're nested 1, 2, 3, 4 in each one of these holes at very specific depths set up by an engineer And the engineer said, let's go and do this. And so that's what they did. As you can see here on the picture, there's a thing called a tough wipe. I recommend you have them in your trucks at all times. They will take epoxy off of things non-destructively. So it's not like acetone, MEK, or anything else like that. Those chemical solvents. It's an organic solvent made with nuts and twigs, and I'm not sure what. I'm scared to think. I don't want to know. It's non-toxic. It's safe to use with your hands. I don't recommend eating it. It tastes horrible. But this is what the repair looked like afterwards. They were going to go re-slurry coat over the top of it, so you'll never see the repair. It's gone forever. This is another type of crack that we traditionally see. This is actually a slab where they had two slabs that came together, and they had originally epoxied the slabs together to keep them there and then put hardwood flooring over it, and then the slabs moved a lot. They kept popping the hardwood off. So this guy said, okay, well, we'll figure it out. We're going to use carbon fiber here, and in this carbon fiber across this crack, and then they froze it in place permanently. Now, if you'll notice, there's another expansion joint right here. They didn't seal that one because they wanted the floor to still be able to move, but this one, they sealed it and held it, and now it won't move at all. Again, this was recommended to us by an engineer, and we went and did the install, so it was a little tough. Here we have an expansion joint here in the top. The expansion joint was here. It cracked from the window due to thermal expansion. So this window heated and cooled much faster than the rest of the concrete. So it created an expansion, a crack here for thermal expansion. We fixed it, tied it all back together, and they put tile over the top of it. You can't even tell the repair ever happened. It'll never move again. As you can see from these little round buttons right here, even if the epoxy were to fail and it were all fall and ooze out for some reason, which never happened, but if it did, they are mechanically locked in place by these little round balls, so it's awesome. This is where we make a huge impact for a lot of people. As you can see here, these are crack locks. This entire slab that you're looking at had something like 2,000 of them in it. It was cracked all over the place. Thermal cracks, as well as expansive cracks, as well as some shrinkage cracking from the original pour. They had all kinds of stuff and they were having fun with it. So the company that did this in Northern California wouldn't guarantee an artisanal overlay from not cracking if it had cracking in the substrate. So now they can, and they do. Now I will tell you, he charges $100 a linear foot, and he had 2,000 linear feet of cracking in this particular location. So he was doing all right on this job. Plus, I got to meet the gentleman who does this, and I could be wrong, but I think he said he was Filipino and Mexican, and I think he was like 926. But he was so awesome to watch because he would stamp the concrete and then come out with a brush and brush on pigments and do things to make it look more like stone. So that was really cool to watch. This is another one that was done in Southern California. And one of the cool things about it was the engineer had a very specific pattern he wanted. So they made templates, which was cool because you can use templates to do just about anything with a crack lock. But one of the things I like to do is have one of the crack locks laid out. Then you put that down, you put spray paint on it, and then go on to the next one and lay them all out. Then somebody else can follow and do drilling and cutting and cleaning and clearing and stuff. And so you can go very, very fast. Again, this was them using that perfing blade at exact depth. They had it marked off on the drill bit so they knew when to stop. All I can say is these kinds of things make your life a lot easier. So what it looked like when it was done. Now, as you'll notice, he has it stretching the crack locks outside of the original crack zone, but it's because this whole end of the deck had tipped it and tilted, and they lifted it back into place, but he needed structural reinforcement across his crack. Again, we work with engineers all day long and have a lot of fun with it. What you see here that I really like is that this is after the job. You can't see it. They skim coated it with concrete, and I believe they coated over the top of it with another acrylic coat, and it was gone. The repair is gone. This is a crack repair in a pool. Very similar nature to the one that's in my pool in my backyard. I have 6 crack locks in mine as well. This is done through a PebbleTech deck. It went down to the gunite. They marked off the cracks. They went down to the gunite, determined this one actually went into the gunite, used the crack locks to repair it. This pool actually had crack in a weird way. The crack went all the way around the pool. So there's a crack on one side and there's a crack on the other side, and the crack went down, but it didn't transition through the bottom. So as you can see here, there's the crack here and here's the crack here. It didn't translate through the floor. And so before that happened and the pool became completely unrepairable, we went ahead and had them do this for that kind of repair. And when they were done, this is what the appearance looked like. You can't even see that there's crack locks in there. Another kind of crack repair that we do is the corner crack repair. One of the reasons that we have these commercials on here, that we talk about them all the time, we can put those commercials, give them to you for an iPad presentation, so you can have a 30-second clip or 50-second clip to kind of show your customer exactly what you're doing in those animations. I know there's a fee associated with it, but if you want to have your logos added to those videos, we can do that as well. We can talk about that. But this is a corner crack repair. In this specific case, it was much more reinforced than we normally do. Normally, I believe there's 4 of them only, so you evenly distribute 4 of those across the load, and that's how they work. This one required more because there was an engineer involved, but because there was an engineer involved, it was a really pretty install. So we use a thing called Gorilla Tape. You put Gorilla Tape underneath there, then you when you put the epoxy on and put the carbon in, you can clean it off the Gorilla Tape very well. It doesn't leave masks or more on the wall. Then as the epoxy starts to tack, you can take the Gorilla Tape off. It's no longer running, and you have these pretty carbon fiber installs. Now, when we start talking about crack repair and strengthening, one of the things that we love to talk about are things where you do multiple things at the same time. So this is actually a crack repair. There was a crack down the side of this wall here and here, and the corner itself is actually separating. It's really hard to tell because there's a gentleman here sitting here with an off angle, but this corner is actually bulging out down here. It bulges towards the street. So they wanted to reinforce it. So what we did was a multiple layered kind of thing. So we did the crack repair here, goes up, goes around the corner. That's a standard crack repair after they composited it back in. And we use a thickened epoxy gel called anchoring epoxy to put in the mortar joints and mortise joints. Then we followed it up with a carbon fiber crack repair. That's a 12-inch wide bi-directional. And then we have a unidirectional that goes around for these corner straps. And again, our engineers talk about it and they talk to the customer, and the engineers help do the preliminary designs. If you require a stamped design, we can get you the preliminary design for our engineers. You can take it to a local engineer who knows all the regulations in your specific area, so you can get a stamp, and then you two can discuss that. I have some engineers that we work with in the past and have worked in the past, but we don't want to tell you who to use, who you can't use. This is what it looks like after it's done. Now, all of us who know there's the repair can find it pretty easily when you're looking for it, but in reality, pretty hard to see if you just look at the wall.